Our first step in factoring a polynomial is always to ask ourselves, what is the greatest common factor, or the GCF? After that, we're going to check to see if any other type of factoring pattern exists. And that's based on the number of terms that we see. If we have two terms or a binomial, we look for a difference of two perfect squares, which is a perfect square minus a perfect square. That's our only other factoring pattern for a binomial. So you can have just a greatest common factor or a difference of two perfect squares. In the other direction, we could have four terms. And if we have four terms, we go through the process of grouping. Just as a real quick recap, remember that grouping is to take those four terms and create two groups of two, factor out the GCF of the first group, factor out the GCF of the second group, and then create our answers based on the common factor, and then creating our second factor by combining the GCF of the first group and the GCF of the second group. Our last one, where we spent most of our time, is with a trinomial. And we started first with just looking at a quadratic trinomial, and we used a process that was called split the middle. And what that split the middle does is take a trinomial and turn it into four terms, so then we could do grouping. After we got good at doing that type of factoring, we looked at a special type of trinomial, which was a perfect square trinomial. And we said that if you recognize that pattern, then you can have the shortcut of going through this process and go straight to the answer. The good thing about it is, if you don't recognize this perfect square trinomial pattern, that you can then just go through the whole split the middle process and do grouping and still end up with the same answer. So now we're going to look at an example of a few of these. So a lot of times we forget that we can't just have a GCF only. So if I look at the first problem here, I have 4x squared plus 8x. If I look at a GCF there, my GCF is going to be both a 4 and an x. Remember, my greatest common factor always goes on the outside of the parenthesis. And then what I would be left with is an x plus 2. And so the type of factoring I would identify here is greatest common factor. And then I would check to see, well, does this inside here meet any other factoring pattern? And since it's a binomial, the only other pattern I would have is perfect square minus perfect square, which it does not fit. If I look at my next problem here in green, it is a trinomial. And remember that I can have a GCF of a number, a constant, or a variable, or a combination of both. In this particular problem, I'm going to have a GCF of 2. Always my GCF on the outside of the parentheses. Now, this may very well be my answer after I've divided out a 2 out of each term, but I have to check. This is a trinomial, and so I'm going to take and multiply the a term times the c term. That would be a negative 5x squared, and then here's my bx term. I'm looking for two numbers that multiply to a negative 5 that would add to a negative 2. Negative 5 would tell me one has to be positive, one has to be negative, and I can see right away that there is not a combination that is going to work. So this one was only a greatest common factor. So we have to remember that if we take out a GCF and if it doesn't fit any other factoring pattern, that is just our answer. We don't want to force it to go to another step. All right, if we look at this problem, first thing I do is look all the way across. Is there a GCF of all four terms? Okay, and looking at this one, there's a GCF of 2. And so I'm going to take first and divide out that 2. And that is going to leave me with an x to the third, a minus 2x squared, plus 2x minus 4. Now I'm immediately, so I remember, going to drop that 2 down to my final answer. And now I'm going to look at these 4 terms here. And I'm now going to start my grouping. So this one had GCF first. And now I'm going to look at grouping. And so here's where I create my 2 groups of 2. Looking at the first group here, I can see that I'm going to have an x squared in common. Remember, I don't have to worry about this 2 at all. I already have it here in my answer. Over here, I'm going to look at a GCF of 2, positive 2. And then I'm about ready to write my answer. See how this parenthesis here and this parenthesis here is the same. That becomes one of my answer. That's the common factor. And then I'm going to look at the GCF of this group and the GCF of this group to create my answer. Remember that one thing that we always want to remember is that if we took that GCF out there at the beginning, that GCF should show up there in the answer. If we look at our next one is a trinomial. If we look at it 6, 7, and -5, we don't have a GCF. And so I'm going to start the process of multiplying a times c. That'll give me a -30x squared and -7x. So -30x squared tells me one has to be negative, one has to be positive. If you need to list the factors of 30, go ahead. But I think we're going to end up with 10x and a positive 3x, because -10 times positive 3 will be -30. -10 plus 3 will be -7. And so now we're going to take that trinomial, we're going to do that process that we call split the middle. So I'm going to drop down the 6x squared, I'm going to drop down the -5, and then I'm going to split this middle into 2 parts based on these 2 parts right here. That'll be a -10x and a positive 3x. Remember, the order that you place those in there does not change the outcome of the problem. I'm then going to take and split this into 2 groups. I'm going to look at the first group here, and the GCF will be a 2x. GCF always on the outside of the parenthesis. I'm going to look at my second group over here. Because this is a positive, I know my GCF is going to be positive, and it's going to be a positive 1. As I go to write my answer here, I see this parenthesis and this is the same. That becomes one of my answers. And then my other answer I take and create from the GCF of the first group and the GCF of the second group. I did not have a GCF at the very beginning up here that I needed to carry through, so there's nothing out in front here. These are just my 2 factors. Okay. So this next one is a perfect square trinomial. Now, what I've told you is that when you go to multiply our a times our c and you get a really large number, one thing you should do then is check to see if this is a perfect square trinomial. Okay, if we look at it, what we should see is that it fits this pattern. This 16x squared is 4x times 4x. The 25 is 5 times 5. But we need it to make a negative 40 in here. And so if we make this negative and negative, if you were to check yourself by either doing box or distributive property, your call. What happens is that we of course get the 16x squared, and we're definitely going to get the plus 25, but these middle terms should add up to the middle term in the original problem. And so if you notice that pattern, then you can go straight to this answer. And then the last one we have today is the difference of two perfect squares. And so what we see here is that 81x squared is 9x times 9x. 64 is 8 times 8. And since we need this to be a binomial and not a trinomial, that means that middle term is canceled out, and that has occurred because we can put a minus in one and a plus in the other. And that is our difference of two perfect squares pattern.